Okay, hi guys. So in this lecture, we'll be talking about golden rules for determining R or S configuration for compounds in Fischer projection. Fischer projection. Okay. So okay, let's start. Uh, for Fischer projection. Okay. Okay. Let me write this J correctly. Fischer projection. Okay. So the first rule is if the lowest priority group lies on the vertical line of the Fischer projection, then um, we don't need to change the configuration. That means R is R and S is S. Okay, so if lowest priority group lies on vertical line of the Fischer projection, then R is R and S is S. So don't worry if you don't understand the meaning of R is R and S is S. As of now, we'll be taking up this topic, the first point, in coming seconds. Okay, so if the lowest priority group is lies on the horizontal line, then R becomes S and S becomes R. Okay, so if lowest priority group lies on horizontal line of the Fischer projection, then R becomes S and S becomes R. Okay, so let us explain, let us understand this with the help of an example. So suppose this is the Fischer projection we have, BR and I. Okay, so lowest priority group in this is F. So this is actually on a vertical on a horizontal line. So according to the rule number 2, second rule, we have that if the lowest priority group is on a horizontal line, then S becomes R. Okay, so what is the configuration of this compound as of now? So highest priority is this, second is this, third is this. So this is a R, but the actual configuration of this compound would be S. Why? Because R becomes S if the lowest priority group is on the horizontal line. As lowest priority group on horizontal line. Okay, so let us look at some more examples of the same to clearly understand this concept. So we have something like this. So CH3 is here, OH, CS3 is this one, OH here, H here, again OH, H, and again CS3. Okay, so what would be the highest priority here? Highest priority would be O for this carbon. Second would be this or this. I think second would be this carbon, not this one. Why? Because this is just CS3 and this is on CS3 we can have O, and here on CS3 we can only find H. So it is R, but as you can see the lowest priority is on horizontal line, hence the configuration of this carbon is S. Similarly on this carbon the highest priority is this, second priority is this. So this is R, but as you can see the lowest priority group, which is S, is on horizontal line, hence the configuration of this carbon becomes S. Okay, let's take another example. We have fluorine, bromine, iodine, chlorine. Okay, so this is the first, this is the second priority, this is the third priority. Okay, so this configuration is R, and also the lowest priority atom, which is F, is on the vertical line, hence R is R only. So the configuration of this compound is R only. Okay, so what if we change the positions of atoms in this compound? So let's say we change the position of one pair of atoms, hence let's suppose F, Cl and Br are exchanging their positions. So in this case we get S configuration, and this was R configuration. Now let's say I changed one pair, so now let's say I changed one more pair, or I can directly say I changed two pairs. Okay, so what would be the case in this thing? Suppose I comes here, Br comes here, Cl and F. So what would be the configuration for this compound? For this compound, configuration would be 1 2 3. So this is again R. So the conclusion is, when I change two pair of atoms on Fischer projection, the configuration does not change. But when I change one pair of the atoms in a Fischer projection, then the configuration changes from R to S or from S to R in some other cases, and the configuration remains the same in case of even pair changing. Okay, so we cannot rotate Fischer projection by 90 degree. Rotation by 180 degrees allowed in the same plane. Okay, so 90 degree rotation of the Fischer projection is not allowed. Okay, so this was just for information purpose. So now before ending this lecture, let's look at 2-3 more examples. So I have you have to this is a sawhorse projection, and you have to draw the Fischer projection from this sawhorse projection. This is the sawhorse projection. So Fischer projection would be CO2H would be here. For this carbon, we have this carbon analogous, so OH is in right, H is in left, and for this carbon, as you can see, CO2H, OH in right and OH in left and H in right. Okay, so what would be the configuration for this carbon? The configuration for this carbon would be, the lowest priority group is on this side, the first priority is this, second is, which would be the second priority? Second priority would be this. Why? Because we have directly attached oxygen atom over here, and here also we have directly attached oxygen atom. Okay, so in this case you can see that the highest priority would be, so if you just draw the CO2H structure, if you just break it, it would be something like this, wherein you have, let me erase this first. Okay, I have sufficient space here only. Okay, so you have COC. Okay, so this is the group which is attached here. Remember, I just used the trick which we discussed when we have to compare the priority order. Okay, so at this carbon atom we have 1O, and here we have directly C. Okay, so this is at higher priority. Why? Because when I go at this carbon, so it has O on one side, and again C. So till now we have compared, we are at CC at both the carbon. Now this CO2H can be broken up into something like this. So we were at this C. Now we are at the highest priority group here is, for here the highest priority group is this, and for here the highest priority group is Obviously this one will be the highest priority group for this carbon. Okay, so oxygen remains the same. They are both the highest priority group. Next we should see the second highest priority group. So here we have CO2H attached, and here we would have only carbon attached. Okay, so CO2H is obviously at more higher priority than C carbon, just a carbon atom. So this carbon will be given more priority. So first is this, then okay, let me just erase it. We are going to discuss this example in the next chapter, but till then let's discuss it in the next lecture. Till then, you guys also consider this question as your homework, and we'll be surely discussing it. So let me redraw it. So we have the Fischer projection as OH, H, OH. So you have to determine what is the configuration at this carbon and at this carbon. Okay, we'll take this example in the next lecture. Okay, till then, good luck and goodbye.